Assalamualaikum everyone and good day, and also I hope you are all doing well. Alright, so for this chapter we are going to cover four subtopics, which is for plot, filter characteristic, analysis of first and second filter functions using transfer function, and finally first order filter design. Alright, so basically for this video we will going to cover Bode plot alone. Alright, okay, so let's start. Alright, so this is what actually the looks of the semi-log graph. Okay, so over the past several years, I think I can see that many students don't really know how to label and use the semi-log graph paper. So actually there is no real trick to it. The only thing that you need to remember is that the log axis run in exponential cycles. Okay, so if you can see, this is a semi-log graph. Alright, so what I'm trying to say that the cycle is actually the one that I marked with the red pen. Okay, so this is the cycle. So basically for this graph, how many cycles can you see? 1, 2, 3, 4, 5, 6. Okay, there is actually 6 cycles in this graph. Alright, so as I said before, it is exponential cycles, meaning each cycle runs linearly in tens, but the increase from one cycle to another is an increase by a factor of 10. Okay. Alright, so within a cycle you will have a series of, for example, 10, 20, 30 until 100, which is a factor of 10, right? And then the next one is going to be 100, 200, 300, and so on until 1000, followed by 1000, 2000, increasing until 10,000, and again repeated with the incremental of increase by a factor of 10. Okay, yes, you can see that. So this is even this basic concept, sometimes the student find it hard to understand, so I hope you will try to understand this part, okay, because this is crucial. So I can say each line, if you see in a cycle there will be like 10 lines, where each line is actually represented by a number, and then it will increase by a factor of 10. Okay. Alright, for like the previous example just now, what I show you is that it started with 1, 2, 3, 4 and so on, and then increased by a factor of 10, which means from 100, from 1 to 10, 10 to 100 and so on. But it is actually doesn't necessarily you start with 1. Okay, like for this example, I'm starting the semi-log graph with 0.01, so meaning the factor of 10 is going to be 0.1, 1 and 10. Alright, and so on. So I want to say here is that it doesn't have to start with 1 or any particular number. You can also actually start with 2, but you are going to complicate this yourself out, so better not. So easily just to start the semi-log paper with the incremental of 1, or I can say starting from 1, 0.1 and whatnot. Alright, so I have explained about semi-log graph paper. Okay, so now we will move on to Bode plots. So what is actually Bode plots? Bode plots are semi-log plots of magnitude in decibels and also phase in degrees of a transfer function versus fundamental frequency omega. Alright, and the transfer function in dB, which is h, is equals to 20 log h. Alright, so before we go to Bode plots, which is magnitude and phase explanation, this is just to recall, where when we have log p1 times p2, it is actually equals to log p1 plus log p2. Okay, this is basic. Another one is if we have p1 over p2 log, it means also log p1 minus log p2 and so on. Alright, so another one, the basic is that a equals to b the power of x is also equals to x equals to log b to a. And another common one is x equals to log 10. A is also equals to x log a. Alright, so let's start. For dot plots, we have magnitude and phase. So basically, there are three terms that you have to remember and to understand. Not just remember, but to understand, because each of these terms, there is a way of you to plot. Okay, each of the term is different. So the first one, we have constant term, followed by pole 0 at the origin, and finally we have simple pole 0. Alright, so for the representation of the plot for each of the term, I really like to simplify it in a table. Alright, so like before, we have three terms: constant term, pole 0 at the origin, and simple pole 0. So basically, actually for each of this term, it will start with the same transfer function. Okay, so from the transfer function, the original transfer function, you will try to form the equation that is similar to the term that in this table. Okay, so it's okay for that. For that, you will see in the example. Okay, in our next video. Okay, so basically, for constant term, the standard form of the constant term will look like 20 log k, which is k is actually a constant. So yeah, when you want to plot it again, the vertical line will be h against the omega, which is the frequency. Okay, because for the constant term, you will just plot it in a straight line like this. Okay, just like a straight line, and label it with 20 log k. So obviously, if sometimes k is any constant, will do. So you will just do the calculation on your calculator and just plot it straight from any value that you will obtain. Okay. So for example, if the k value is 10, meaning you will plot a straight line from a 20 decibels. Okay. Alright, so this is for constant term. The next one is for pole 0 at the origin, again for magnitude plot. So for the pole 0 at the origin, the standard equation will look like h dB equals to 20 log j omega. Alright, so how to plot a pole 0 at the origin is just that. Okay, that is like the increment of 1 from 0.1 to 1, and then 10, 100, and so on. So what will happen is that you will do a straight line from -20 going through the origin, which is 1 in the middle, and straight down to -20. Okay. Oh, I'm sorry, it's going to go straight up. If it is positive, it will go up. Okay, so what is that? The mark is that you are going, the representation is that 0.1 will be at -20, and then 1 will be at 0 decibels, and then for 20 decibels it will be on the 10, and then you will just draw a straight line from there. Okay. Alright, so if for cases that you have -20 log j omega, the line will go down. Okay, just that, don't worry. If you understand this, you will not have any problem during the plotting. Alright, so now we are going to go to simple pole 0. So for simple pole 0, the standard form looks like, yeah, HB equals to 20 log 1 plus j omega over Z1. Z1 can be any constant, okay? Any value. So according to the Z1 is actually where you are going to plot. So for example, if your Z1, okay, so in this example is that I didn't really put any value. It's just that the first plot will start with 0.1 Z1, meaning negative factor of the Z1. Okay, so for example, your Z1 is 1, so you will start plotting from 0.1. Alright, and we'll end at 10. The factor of 10 of 1, which is 10. Okay, so let's see how we plot it. Yeah, straightly like that. Okay, but you have to remember that you have to start your plot from the 0.1 of Z1. So meaning you will start plotting from 0.1, Z1, and the and 10 Z1. You have to remember one more thing is that it is the incremental of 20 decibel. Okay, so if you see here, 0.1 Z1 is start from 0 decibels, and then Z1 is at 20 decibels, 0, I'm sorry, and then for 10 Z1 it will start with 20 decibels, and actually the line will go straight. If you have like 100 Z1, it will be at 40 decibels. If you have 1000 Z1, it will be at 60 decibels, and so on. Okay. Okay, so for this one, the line will be continuous, okay? And then the purple line again will represent the negative representation of the simple pole 0. So just to easy to understand is that it will be the mirror image of the original signal. Alright, so that's all actually for magnitude plot. Now we will go on to the phase plot. Okay. For phase, you have to bear in mind that the incremental on the vertical axis is actually not decibel, because before this we have the incremental of decibels, 20 decibel, which is 20, 40, 60, 80, and so on. While for phase, the incremental is actually in degree, and you can start your degree in 45 or 90 or so on. Okay, so if you start your value in 45, for example, it will go from 45, 90, 155, and so on. Alright, so for constant term, how you plot it is very easy. It is actually 0. The degree is actually 0, so meaning you don't have to plot anything. But if you want to plot it, no problem, just to label it, okay? Alright, so for pole 0 at the origin, actually the value is actually 90. Yes, only 90. As easy as that. So when the phase is actually 90, what you have to do is do a straight line at 90. That's all. So what I can see here is if there is a pole 0 at the origin, basically for the phase plot is just a straight line at 90 degrees. As simple as that. And again, sometimes we have a negative value, which is negative 20 log j omega. Then the representation will be in negative 90. Again, straight line at negative 90 for negative pole 0 at the origin. Alright, so next we are going to go to simple pole 0. So for simple pole 0, if you find this type of term, the phase plot of the term is actually quite similar with the magnitude. However, it is slightly different. First of all, of course, the value is different. Before this, we use decibels. So for phase, we are going to change the value to degrees. Alright, so actually, for decibels, we will, for phase, we will start the plot at 45. Okay? Alright, 45 for the positive value. So I'll just put the label for the negative value. Alright, okay, for the magnitude, do you remember that we plotted from Z1, where the 0.1 of Z1 will still be 0, but for phase, it is actually different. Okay, so as I said before, we'll start plot at 45. Okay, see? So actually, we still have 3 value of Z1, which is 0.1, Z1 and 10. Still the same with magnitude. It's just that for magnitude, we will start plotting at Z1. On the Z1 value, we will go up, right? So however, for phase, we will start at 0.1 of Z1. So from there, we will go up 45 degree, continuing to the 90 degree that represent the next factor of 10 of Z1. Okay, and then after that, it will be straight line. Remember, for phase, it will be straight line, not continuous. And the other line is actually for the negative value of simple pole 0. So if you have a negative 20 log 1 plus j omega of Z1, the line will go down. Okay, just that, the mirror image. I'm sorry for the same color, kind of confusing. I should use purple color for the line going down actually. Alright, so I think that's all actually for the basic of you on how to plot the phase and magnitude for constant term, pole 0 at the origin, and simple pole 0. We will see you all in the next video for exercise 1 for more understanding. Okay, alright, so that's all. Assalamualaikum.